We are Victor Rubesten
and Henrik Lundgren.
We are two last-year mechanical engineering students who are currently doing our masters in mechatronics.
This summer we did a research project, part of a collaboration between Newton, Nordic and LINK-SIC.
The aim of this project was to find a better solution and a more automated way of tuning the PID parameters of their main product, a camera stabilizing system Newton.
Every camera has a different moment of inertia. This means that the PID parameters must be tuned in every time you change the camera or lens.
The approach was to find a way to automatically find a system model of the system and then use tuning laws to find an appropriate tuning.
The approach we used was that we started by trying a first order transfer function of the system, which would coincide with the theory of a BLDC motor.
First thing we noticed was the system was not stable without feedback. This is problematic if you want to use classical system identification methods.
When you manually move the system, it seems to have no friction at all. Therefore, the assumption that we could neglect the friction in the system.
From the model estimation of the first order systems, it showed that the systems only worked around the given working point. When we changed working point, the model failed to simulate the true system. This indicated in a non-linearity in the system.
This non-linearity, after a lot of investigation, seemed to be dominated by friction. When we used a non-linear friction model with our first order model, this result was promising.
The linear model around the given working point was used to find suitable PID parameters using pole placement. This seemed to work close to a working point, but the problem is that the Newton rarely moves around one given point.
Expanding on our work, the next step could be looking further into advanced friction modeling. With this model, you could then use techniques as gain scheduling or some version of MPC.
Thank you.
Thanks.